everybody. We are talking today about stream gatherers. Some words about me. My name is Karl Heinz Marbaise. I'm a Java champion. I'm working as a freelance in Germany. I am Apache Maven PMC member and things like that, Apache Software Foundation member and all that stuff. Maybe you can read that or use the QR code and find some information for relationship and some contact information. Let us start with a bit of agenda. We talk about a little bit of the JDK releases, stream operations, gatherers, thinking experiment, thought experiments, and most of the time I will show code examples here. We start with the basic idea here. The basic idea of the stream gatherers was to improve the stream API because the stream API has some kind of limitation in some ways, because you have some limitation because we have only collectors, for example, which is a terminal operation. We have intermediate operations, but there is a limitation in the intermediate operation because you can't implement your own intermediate operations, and that's exactly the point for these so-called stream gatherers. Exactly that point here is the particular one. We have some information about the different JDK releases. We started with JDK 22, where the JAVAPRO 6.1 was the preview feature in JDK 21. There were some smaller changes, and that has been continued with JDK 23 with the JAVAPRO 7.3. And finally, that got being part of the JDK 24 since 18th of March of this year. That is wrong. That was 25. Sorry, that is wrong in the slides. So based on that, the JDK 24 has now these stream gatherers as part of the JDK, formally part of the language, and can be used in continuous in your production code as well, if you need it. Or if you even on JDK 24, maybe you will change later on with the JDK 25 with the next so-called LTS release. We have some basic information. I would make a small recap about the difference between the stream operations. We have in general some kind of source, an array, a collection, or something, a generator function, iterator, or an IO channel, or whatever we are talking about, or reading from files and so on. That's usually the way to get a stream in some way. What we have then afterwards is some kind of intermediate operation. I already talked about that. So you have things like different map operations like map, flat map, filter, and all that stuff. And there are two different kind of intermediate operations at the moment. They are called map, filter, map multi, flat map, and so on. These are so-called stateless operations. And we have also so-called stateful operations, like distinct, sorted, limit, skip, drop while, take while, and so on. Because they are making a difference here, because it's most of the time easier to use them, because you can better optimize them and things like that. And we need to think about, if we would like to implement a gatherer, we need to think about, do we need a stateful operation or a stateless operation? And finally, of course, we have always the terminal operation. And based on what you know, hopefully already, that if you start a stream based on the triggering of the terminal operation, the whole thing will start, because it's a lazy evaluation. That's very important here, because if you do just simply a stream, it will not happen anything until you do a terminal operation here. So that's the most basic part here. Let us start with a assumption here, just a single thinking experiment here. That may be a little bit longer than a second. Yeah, sorry for that. But let us think we don't have any kind of intermediate operation like map, filter, limit, distinct, and all that stuff. That we think we don't have any of them. So let us think about that, getting in our head here as an example here, and think about what couldn't we do with all that? But let us think about that. I just walk to code here. I hope you can already read that, in particular the higher rows and those. So that's good. Thank you for that feedback. So we have here a simple thing here like a map function. A map function does usually map from one to another thing. I have first here making more or less useless mapping here with function identity. That means we're just mapping without doing anything useful. That can be done with a real mapping function, doing some functional things and so on. I will not take too long here, but we are starting with the stream gatherers. We would like to implement that, and you see the only thing here which is different here, then instead of using stream.map, we use stream.gatherer. And that is the position where we can interfere and put into our own implementation. I have started with a simple one here to get the basic idea here. How looks a stream gatherer? You have to implement a particular interface, that is the gatherer. You can look up into the documentation. The basic information is to start with a so-called integrator. This is an integrator. You can imagine that based on a tube, for example, where the elements are coming through. And the integrator will see exactly that element which is coming through. And then you can do more or less everything with this single element. There are different parts here. This is the first one, which I have defined here with void, and use the underscore here because at the moment it is not interesting for us. We are just interested in the moment with this element here. This element is, of course, that is one when it's coming through that tube, and then you can use that to do something. Then we have another part, which is the so-called downstream. That means, from my perspective, I'm in the gatherer here now at the position here, and that we have something which is before us, which we are consuming, and on the other hand, we are pushing downstream, so-called. That means another part of this stream or other parts, like other intermediate operations, like anything else which we can do. So I have done that a very simple example here. So I just push that element here just downstream. Very simple thing here, nothing fancy for the first example here. Let us just run that in a very simple manner. If I could type that in the correct one. So what you see, very obvious. I printed out the information here. That's not very fancy here, something like that. And of course the result, because I have just implemented a simple one which does nothing in the end. It just put them through the line here, nothing else. But we can do that in a more different way. We have to call that off-sequential. If off-sequential means this gatherer is first not parallelized at the moment. It's just using that in a sequential way here. Very simple at the beginning. Now we will like to implement a gatherer, a mapper here in this kind of way, which is really doing something. More or less the same way, you have to implement and call the gatherer you have implemented, which now looks a bit different, just a bit. You have a function which is the mapper. If you could look into the stream map, it's exactly the same here. Nothing different. The same thing happens here. We have the integrator, so-called. We use the element and the downstream. So the only difference here is this line with mapper apply element. That's exactly what the mapper does here, the function call, and the rest is the same here. So I can now just call that here, and of course get the same result, the result based on my mapper multiplication by 2. That's the simple thing here. Very simple stuff here. What I can do also is with different objects, for example, or classes, to map onto a particular gather from a record here, just produce and extract the name of that. Very simple one. As you see, the result here, only the names of the persons have been mapped here to the rest of the stream. Very simple thing. We can do that as well with a filter. We use the same approach, stream, gatherer, and our function here, method, and do a filter. A filter is more or less nothing different than using a predicate instead of a mapper in the end. So the implementation looks a bit different here now. We use the integrator, and if you take a look here, we have, just as an imagination, on the left side coming in the elements here. So we take a look on that element and try and check the predicate, which is used as a parameter here. And if that is true, that's exactly what the filter does in the end, we push down the result. That means we give down the element which we are consuming here on the left side and put it to the right side. There are two things to reconsider. We're using here a return true. That is always a Boolean which we return into the integrator. The integrator, with that we are talking to the previous part of the tube that's saying, okay, we would like to consume more of what we like to get here. So on the other hand, we can say either true, that means give me more of them, or just false and so stop, I have enough. I don't want to consume more elements here. So I can make the decision for different circumstances here. Very, very easy one. I have done the same thing with person here, more or less the same thing. The predicate is a bit different here, and the result is more or less the same. So that is exactly what a filter does. So we can continue with that. Just taking a look with stateful parts, which uses a limit or something like that. Just wanted to take a look here in an example. And now we have a difference because we need something, a state, because we haven't used a state before. We have just looked at the elements, but not the state. There was no state. And now we have a difference that we need to have a state. And that's the time of the so-called initializer. The initializer is needed to create a state, whatever you are using as a state. State is simply a class, an object, a different list or something else, which contains the state you need for your operation. In this case, we have a simple one. We just needed to count the elements. I've used here an integer array, which is simple. You can't use, of course, the wrapper classes because then autoboxing is kicking you in the behind. Sorry to say that. But you need to that. You can use a class with a simple anonymous class or something like that. That works as well. So now you see a difference here. There is not anymore a void here. We are using something different. And that exactly is very important, that with each element it's coming through, the first time the initializer is called, creates the state or the state of your whatever you are doing, and then each time the integrator is called, you get this information, the state, or in this time I have called that a counter, and you can do with this state whatever you like. In this case, I just simply counting down, just simply doing that, and based on that, if it is greater than 0, I push the element downstream. If that reached that limit, I stop pushing down elements. Very simple. Next one, we can do that with a skip as well. It's very more or less the same here. We have a state. We have a little bit different logic here to count that, but in the end is the same here. We have a state which is put into the integrator, is initialized by starting the stream here. That's more or less the same thing here. And then we are starting counting here. And if we have not reached the limit here, here's a little bit different. We are saying just directly, if we not reach that state, we are pushing that element until the state we have reached the number of elements, as limit exactly as skip in this case does. So we have implemented limit, predicate, map means we have implemented a filter, we have implemented a limit, a skip, and things like that, just using the gatherers here. As you see down here in the last count line, we use always this of sequential. At the moment, we are not parallelizing in any way, so we'll become late. We're coming to later than that. We can do the same thing with things like take while and things like that to do a different style here. That's looking more or less the same way. I changed the code a bit to get better reading here. A take while is just a predicate, and the most important thing by using a take while means the first time this predicate has been satisfied, after that it will not turn back, so it stops. So we have a take while, we have a drop while, so the first time it is changed, then it will keep that state and will not continue until during the pipeline. That means also if you have not sorted elements or something like that, you must be careful how to use a drop while or a take while. This is often very misunderstood here. So the same thing here, the supplier will create an instance of that, and that is the state which is as a parameter given to my integrator here. So far, more or less easy. What you can see is I have a difference here to say, okay, now I say if I reach that point and say with my return equals false, return false means to my for part from the tube, I say, okay, now I have enough elements. I would not consume any more elements. So that is a signal to my previous element or previous part of the pipeline to say, stop, I have enough elements. I don't want to consume more of that. That's a very important thing here. Otherwise, I would like to push the element downstream, give the other elements downstream and further into the downstream based up part of after me here and that, and then say, okay, true, okay, I want to continue with other elements here. So we have two different states. One is saying, okay, I don't want to anymore any elements, and the other one, continue, please. So we have a system here. Later, please. So next one, drop while, just a little bit different. I would not go into the details here because it's more or less the same here. Just the logic is a bit different here. So we have the initializer, the integrator, and the logic is a bit swapped here, when to continue, when not. So now we have created some basic things from the JDK, which are already existing, but now we want to do something which is not existing at the JDK at the moment. Maybe you have already found something like that. I would like to create an index in a stream where you put an element in there and increment an index with that during the consumption of your stream. That is more or less easy to create with the stream gatherers. I have created a different implementation here. I have one implemented with a default set, one with a start value and an increment with different things. So what we need to do is just to implement that a bit different. I've created me some helper functions here, and the real part here is it looks like that. So the same thing here. There are some differences here. We have so-called, I call that gatherer with index, of course. We create a part which is integrated into that stream. And we have, of course, an initializer because we need some state to increment somehow in some ways. And then we can do that into the integrator the same way. It's a bit different here to take a look at the greedy part. The greedy part means if we take a look into the documentation here, they consume requirements and it's not short-circuiting. Yeah, that's a very important thing here. You should really read the Java doc here. That's very important to see these differences here. What we do here is simply we consume the elements and create a new record with the counter, with our element, of course, based on the generics here. It's more or less easy. And then we increment that counter here based on that function which we are on that unarray operator, which are produced here based on the parameters here. And the thing here is that we keep using of sequential because we are not parallelized at the moment. So what we can now do is to run here some tests. Very basic things here. I started with a simple start value. What you can see is we get a record with an index. I use a start value different than 1 or something like that. Or I can do with a different increment as start value, and my increment is not +1, it is +3 every time. So we can make that very easy to make different counting here. Very easy. You can do that with starting with a default value. I have implemented that as well. So it's very easy, more or less. Starting from 0, sorry, not from 1, but it's easy to change to do that. So what we can do also is, if we don't want to use a supplemental defined record for that, we can do that also in a different way and using existing parts in the JDK, for example, and implement the logic a bit different and using a map.entry, for example, for that. Instead of creating an own record, for example, the logic is exactly more or less the same, but I use the map entry instead of that. So either you prefer that way or that way, it depends on your use case, of course. Works basically the same. The only thing is, in this case, I don't need to create a supplemental record implementation or a data type for my own identity or my own domain. Maybe in your use case, it is better to use a domain-specific implementation, a record which is named accordingly, but that really depends on your implementation or on your needs. What we have also are things like distinct or things like that. As you know already, they are based on the equals method and things like that. I will not repeat the older one. We can take a look into the implementation for the gatherers. So how can do that? So you see a different here, because now this so-called initializer uses not a Boolean array or an integer array. We use really a hash set in this case. So whatever you need to make a state of, that can be created. That can be a whole class. That can be a simple thing like that, or the last examples I used. So you can make different things here. So there are some differences here. So what I use here, of course, is the state, because that's technically a hash set. So if I add that, I get a Boolean true if it's added the first time. If it is added the second time, I get a false, so I can identify, does that already exist in that set? Very simple things, you can use that here very easily. If that's the first time, so I call the downstream push. That means, in other words, a distinct works like the first occurrence of an element based on the equals code and things like that is automatically pushed down into the stream. If it is not the first time, then we don't add it to the downstream. So we are filtering out indirectly these duplicates or something. That's exactly the idea of a distinct. So the order is not correctly held or kept. So we might implement something different, that the first is used, the second is last, or the last is used. That only depends on the implementation here. So we can do an implementation exactly for that. Distinct last. So we would like to have that the last element which is added, or the last in the stream, will be pushed downstream. So we could make an implementation in some way. We need to do it a little bit different, because we need to get the order of the elements as they added during the time base they are consumed. But the problem is, you can't make a decision finally, because we have only the initializer, the integrator. But what is needed here is to do something at the final end of your operations. And that is the point where it coming through is the so-called the finisher here. And that is the next part of the gatherer API. We have so the initializer, the integrator, and now the finisher. And the finisher is the last one which is automatically called if that part is ended. So we are adding these elements to our linked hash map, put them into that hash map, and we are telling the before part of the stream to say we would like to consume everything, because we can't stop here, because we don't know if it's the last one. Because if you think about 100 elements, you must go through all the elements, otherwise this is not possible. So the final part is, if that stream is ended, you need to do something with the state. And that's the point where we're coming to the finisher. The finisher will be consuming or getting the information, the so-called state. In other words, what has been created by the initializer. So that contains now the elements, and now I can work on these elements and push them downstream very easily. This is one implementation. Maybe there are better ones, but it's just an example of that. The other question is, do I handle here correctly the iteration order, things like that? You should be really careful about that, because then you should really think about, is the interset here the correct way to do that? I have a linked hash map, and you need to really care about the iteration order, for example. And that's very important to handle these cases very, very distinctive and very correct. which is very easy since 22 there is a called get last, for example. Sorry, 21 was the one as the sequence collection that has been inserted, and that makes it very easy to call that here very easily. So that is the third part of these things which have been integrated here. So you can do everything from by using an initializer to initialize your state, which is a kind of a storage or memory, however we call it. The integrator is working on the single elements, and the finisher is doing the work after every element has been consumed here. We can do that a bit different also with other parts here, with strings or something like that. That can be done with other objects and implementations and things like that. So you have to do that in a different way. We can do a distinctBy with a kind of a function to distinctBy, because a standard distinctBy does not have the option to do a classifier or something like that, because you don't have it. Does not exist something like that. So the code looks a bit different here. So we need to do this classifier here and to apply that onto that list as well. So finally, we do need to do the finisher as well to work on all the elements here. So if you take a direct look here, this is working different. The distinct here in this case works differently because the order is here different. So it's very important to think about exactly these iteration orders and things like that. So the next thing is you have often the requirements to do something like a sliding window or something like that. That's a use case which is very often occurred. You can do this with collectors, but yeah, kind of, or stream things that is possible to do, but it's not very easy to do. It works, yes, but it's not very easy to read that, and that is much more easier to do here with the stream gatherers. What we do is simply we would like to do a statistics in the window here, very simple, and say I have some values. I would like to calculate a statistic based on these values here. Let us take a look. I will run first the code to see the result, and then we look into the implementation. We have 1, 2, 3, 4, 5, up to 10 here, very simple. And then you see here I have two elements, 1, 2. I would create using the double summary statistics, which is nicely in the JDK. You can use that to calculate some basic thing, the sum, the average, and things like that, min, maximum, and so on. That's very easy. But now we would like to get that, as you see, to 1, 2, 2, 3, and so on. And now let us take a look into the implementation, how it looks like. What I have done here is created a record which contains these information nicely with JDK 16, since that the record is very easy to handle. And then you see this sliding with statistics needs a window size, which I have defined as a parameter. And then I need to do initializer, this state. I need to store that information somehow. So I used a simple array list at the moment. That is not perfect and maybe not the best performance. If you would like to have some ideas how to do in a very performant way, just take a look into the JDK implementation. They are using in some ways their own gatherers API and give you some good hints how to do that in a very performant way. What I have done is to use the integrator as we done before, so-called the state. As you see here, IntelliJ gives me some hint, list integer and things like that. So I could add that into my array list. I can check the size here, and the statistic I use simply the stream API another time and summarizing that in a very simple way. That's very easy to do with the API here already. So I reusing also the stream within the stream gatherer, of course, but it makes sense. You can do that in a different way, maybe a rolling average or something like that. That might be more performant, yes, of course. Sorry, but that is much more easier to write, to be honest. So I create a new instance of that window average, make, of course, a defense copy here, which is very important. So because with these integers, it's not a problem, but if you have really objects or something like that, if you don't copy, that might be not a good idea. Then I push downstream the result, the complete result, and then I just remove the first element from my array list. So put always the ones into my array list, and then the first one will be deleted, and then I only add at the end always. So it's much more easier to understand. And in this time, it is very easy. I don't need a finisher or something like that, because everything can be done in the integrator here at the point. So we need to go a little bit further and do a window, a fixed window size and something like that. We can do that, and I've written some tests here. These are 10 elements or something like that. That's more or less the same working here. And you see the result. We have 101, 10, 11, and so on. That's working fine. Okay, not a big problem here, but we use a different size of elements here. As you see, these are 9 elements here. We can see that very nicely. And now we wanted to do the same thing here. That works so far. We can create 3 parts, sliced by 3. That works fine. But what is the point if we have only 5 elements and sliced by 2? Okay, so far, nicely my test fails because it already tells me, okay, there is something wrong, which means I need to do and handle the last case here because I have only 1 element because it's odd element number. So that's exactly the point where I need to handle these things. And we need to do more or less the same. We have an integrator, we are checking the size, making a copy. In this case, I do a clear here because I would like to move that window completely and not only by 1 position. And that's the case where I need this integrator, and that will not work because odd element sizes will not be handled correct in this case. So we need to do that in a different way. So we need to implement it a little bit different here. So the initializer and the integrator is more or less the same, or not more or less, it's exactly the same. So we need to have this finisher as well here in this case to handle that last part, or that is the window is not filled completely up because we have an odd number of elements and things like that, which is not dividable by the window size and upfront. So you can check this here if the state is not empty. So it means there are elements in there, and then I can use the downstream push to do that here. So you have to think about what you're doing in your integrator. What is the handle of it? Do you need a finisher? For example, in this case, you need a finisher because you can decide that only at the final end of all elements, or have you just, is it enough to use the integrator? So can I handle all the cases I need with the integrator? In this case, you can't, so you need to have a finisher for that. So that's the simple thing here. And that's the parts you have to decide during your implementation and think about these parts. We have some other things. So the question is, we have a number of elements here. So integers, there are 10 elements here in this list, for example. So the question is, how many times will this line be executed in reality? 1, 2, 3, 4, 5, 10 times. What is your guess? 3. So you are an expert. So yes, that's correct, of course. Why? The very important thing here is why. I'm sorry? The tricky thing here is that limit statement here. That is the most important thing. That is exactly the point where it is limited by. And that means also that the stream or the limit will tell you, or tells the before mapper, no, we don't need to continue here. And exactly this is the part where I said before, this return value of our gatherer is exactly for that purpose, is that for the purpose we need here to get this information here. We can do that and combine that in a little bit more complex way here. It is also handled handled in different ways, like this one. The first one is written also 3 times, and the second one is also written 3 times. So we have 2 different things here, which will be called and printed out accordingly. So the first part is printed, the second part, and this is also written down 3 times here. And so we need to think about exactly this purpose here and see how it works with this thing. I have the first part in line 79, you have a limit 3, and in line 84 you have a limit 2. So the question is, how often will be the first map being executed in the second one? So, yeah, correct. This will be executed exactly 2 times. Exactly. So the first time is saying after 3, but the second one is saying before that. So we can do that and change our things and go to limit and see how that is working. So we need to check or give the information, have 2 informations. We have one, the return value itself is 1, which is using like the limit one, and also we have a return value of the downstream push. The downstream push has also a return value, which tells me my successor set tells me, oh, I don't want any more elements here. And that's very important to check these states here. Let us take a look here into a different one. So I need to do that here in this one. So to check these things here, it is very important to check what the downstreams already told me. So we have 2 checks we need to do. That is one, if I need to consume more elements or should I stop? So telling my predecessors. So telling, oh, I don't want any more elements. And on the other hand, my successors are telling me, I don't want more elements. And exactly this should be done in your integrator or even also in your finisher and things like that. You should check in both cases. That means we have to take a look into the first check line should be is rejecting, means the downstream says, I don't want any elements anymore. And on the other hand, we need to check during putting elements into the downstream, and take while is a very elegant way to handle that here. Hopefully you see that you just checking that is rejecting. So I put many elements here because I use a list here in this case, but you have to check for each element. And if you have thousands of elements, it is much more better to check, and if the downstream says, oh no, I have enough, you should stop, of course, pushing down elements because it's useless in the end, of course. And on the other hand, if I already received the signal from my downstream is rejecting, then I should also myself saying my upstream, hey, sorry, we have enough here in that case. And that's most important here, to check both sides of your integration, because you are in between in an intermediate operation here. That means you should check downstream and your processor. What is happening here? So need to keep a look on the timing here. We have also new things into the gatherers, and they are very interesting things, like map concurrent is, for example, very interesting. You can start different threads, and by using a max concurrency means that if one of these concurrency threads already reaches the result, it will be stopped, and both of them will be stopped if they are resulting. These can be used, for example, if you have a REST API calling from a weather service, like something like that, and you have 3 of them, and you want only from one an answer, which is completely enough. You say, for example, 3. And if you get already an answer from the first one or the second one, whichever, the rest will be automatically stopped. And that's very easy to handle here. And that makes it very easy to handle that. As you see, started 2, 1, then started 10. Task 10 was interrupted because we have already 2 of them. So that's very easy, and I think a very useful thing here for the Stream API here, Stream Gatherer API. We have also scan things like that in the Gatherer API. because the very important thing here is we have scan and fold, and it is very important to say that the standard reduce is not defined that the order is particular always the same, because if you take a look into the stream reduce, there is a very important code line in the Java docs that says it is not guaranteed that it will be executed in the way you might expect. Let me take a look. Reduce. So it is always so far so good, not a big problem. I need to find that point where it is documented. That was one point where I used to see that, but there was one thing, and which is called extension point. Where is it? I didn't find it at the moment. Sorry. Need to look it up. Sorry for that. But you can use the scan for folding things like that. We have scan and fold, so that is already into the stream gatherer. So-called the window fixed is also already implemented in the gatherer interface, and you can use that. Also, the window sliding is already implemented. And if you take a look into this window sliding, sorry for that. Just a second. And if you take a look into that, that's a bit different than you see there's a class with an object, usually based on primitive arrays, primitive with objects, very, very simple. That might be better for performance, but the implementation I've shown are not based on performance. I just wanted to show as examples here on that point. So these are the points. I think, okay, I have 4 minutes. Okay, then I'm done so far. Do you have some more questions? Just 2 or 3 some examples. Sorry, just missed something. So we want to do a parallel stream. We can do that with a gatherer as well. So the only thing you need to implement to support parallelization is one thing, which is called, now I'm just wrong here, sorry for that. Fixed. Nope. Where I have the example. That's not good. Sorry for that. Parallel duplicates. Gatherer parallel. So we can use this one. We have a so-called, no, that's wrong. Sorry for that. Just lost the part. So I think we are out of time at the moment. Yeah, sorry. Then I have to stop here. Okay. Thank you very much. If you have some question, I'm here for the conference. If you want to ask further questions, I'm available here. Thank you very much. Maybe we have 2 minutes. Maybe we have some questions.
Downstream, you mentioned downstream .is rejecting. Is that a should or a must?
I would say it's a must. You should check always the time, because if someone is downstream stopping already, then you continue working on that, and it's better to accept that state and this information that it is already stopping there. Yeah. Yep. Cool. Yep. That's true. Yeah, you can do different things. Yes, the downstream push returns a Boolean value, and you can use that as well, because the is the is rejecting is a bit before exactly the push return. Because if you call the push, you have already executed the push. That's the point here. Yeah, true. Some other question? Otherwise, we are out of time. Thank you very much.